This is a neutrino. So neutrinos are really cool because they're virtually massless and they have no charge, and billions of them pass through your body every day, but you don't feel its effects. One equation neutrinos are involved in is if a neutrino gets really close to a neutron, that facilitates the change of a neutron, the decay of a neutron into a proton. So if a neutrino gets really close to a neutron, that neutron will change or decay into a proton, and then the last thing that comes off, because we have to balance the charge, if I've got a positive proton here, I'm also going to get an electron. So my neutron changes into a proton due to the exchange particle of the W bosons or the Z bosons, and we use Feynman diagrams to figure out which, and my neutrino then changes into my electron. Another equation neutrinos are involved in is when archaeologists use carbon-14 to look at radioactive decay, to see how old bones could be, how old wood could be. So what they look at is they look at the proportion of this carbon-14 that decays into nitrogen. And if you look at the numbers, what's happened here is the proton number is increased by 1. So this is because a neutron has decayed into a proton. So when a neutron decays into a proton, because a proton's got a charge of +1, that's why we also have an electron coming out. So an electron, we know from science, has a charge of -1. And then the other thing that gets released is coming back to our neutrinos, is that we get an antineutrino released. So this is the equation that helps us figure out about radioactive decay, because the probability of this neutron decaying into a proton is really well known. Follow me for more physics content like this.